We're going to start looking at trig. Of course, trig starts with a look at the good old right angle triangle. And we name our right angle triangle, and the longest side is, of course, the hypotenuse. And then depending on which angle we're referring to, so I'm referring to the one at the top there, cleverly we call the one across from the angle opposite, and the one next to it adjacent. So that brings up our first three ratios: the sine, the cosine, and the tangent ratio. But there are also the reciprocal ratios: cosecant, secant, and cotangent. Right, but there's our reciprocal ratios. Why do we have the reciprocal ratios? Well, it's all to do with actually what we looked at yesterday, inverse functions. Remember the notation for inverse function was that -1? So in trig, when we talk about an inverse sine or an inverse cosine, we write sine with a -1. But of course, that's traditionally where we put the power on a trig ratio. So we don't get that confused with the reciprocal of sine, we have the reciprocal ratios. So instead of writing sine to the power of -1, we would write cosec and so on. So that basically is the purpose of the reciprocal ratios. All right, let's start with something very basic here. Sine x is equal to the cosine of 25. Co, of course, means complement. That's where the name comes from. And complementary angles, if you recall, add up to 90 degrees. So sine of x is cos of 25, then x must be 90 minus 25, the complement. We're assuming we're in a right angle triangle here, of course. So x is 65 degrees. But that means we can solve things like this. Cotangent, the complement of the tangent ratio. So these two angles should add up to give us 90. And so we just solve that little equation and we get x is 40. Okay, there are basically three trig questions you could get if we're talking about a right angle triangle. So something like this, where we have to find a side which is not the hypotenuse. We have to work out which ratio we're talking about. We have the opposite side, we have the adjacent side, so we'll go with tangent. I mean, I could go with cotangent, but that wouldn't be a smart choice because we don't have a cotangent button on the calculator. We have a tangent button on the calculator. So a over 13, tan 61, 13 times tan 61, and we get a. But of course, we could find the side that is the hypotenuse, and in this case, what I'm trying to find is on the bottom of the fraction. Again, I could have said cosec, but I don't have a cosec button, so that's not really going to help me. So sine, in this case, I divide by the sine of 32. So when I was first learning this stuff way back in whatever year it was, year 9? Is that when you first did trig, you know? Yeah. Way I basically saw it was that, well, have a look at where the pronumeral is, and that's going to tell me whether I divide by the trig or multiply by the trig. If it's at the top of the fraction, I multiply by the trig. If it's on the bottom of the fraction, I divide by the trig. We get 9.4. The third type of question, of course, is if it's the angle that we want to find. So in this case, it's the cosine ratio, and that's what I was talking about with inverse cos. So theta is the inverse cos of 10 on 14. So that does not mean the reciprocal of cos, it means the inverse function. Go back the other way. Take me back to find the angle. And this one to the nearest minute is 44 degrees 25. So they're the three basic trig questions you get. Exact ratios. There are some ratios we just know what they are off by heart and we don't worry about going to the calculator. How are they created? Well, here's a triangle. It's an equilateral triangle, all the sides are 2. But I'm going to chop my equilateral triangle in half, which creates the 30-60 triangle. Bit of Pythagoras, we can work out the other side is the square root of 3. Then I can simply read off my triangle. So sine of 30 is a half, cos 30 root 3 on 2, tan 31 on root 3, sine 60 root 3 on 2, cos 60 a half. Notice 60 and 30 add up to be 90, and we have the same answer. And tan of 60 root 3. The other one we have is 45 degrees. So to do that, I create the right-angled isosceles triangle. I'll make the sides 1 to make life easy. Hypotenuse is root 2. So we can read off that one. Sine of 45 is 1 on root 2. Cos of 45 is 1 on root 2. Tan on 45 is 1. They are exact ratios. So again, back in year 9, whatever it was, how I used to remember these was just to simply draw the triangle. And then I could read off them. There is another way, of course. If you draw up a little table like this, sine, cosine, tan, 0, 30, 45, 60, and 90, there's sine. Beautiful pattern. Root 0 on 2, root 1 on 2, root 2 on 2, root 3 on 2, root 4 on 2. That gives you the answers. Cosine reads back the other way because it's the complement. And then tan, well remember, tan is sine over cos. So I just put the sine over the cos. I don't need to worry about the denominator because the denominator is the same in both. And bingo, you've got the different ratios. Might not be in the form you're used to seeing, but they are of course equivalent to the exact ratios. So trig, measuring angles, important part of it. How do we do it? Well, there's these things called angles of elevation. And it is exactly as the name suggests. From the horizontal, how far do we elevate or rise? So that angle there, how I would say it would be, it's the angle of elevation of B from A. So it's from where you're looking from, if you like. So if you're standing at A and you want to look at B, you have to elevate your eyes. That's the angle we're talking about. Angle of depression, similar thing. You've got the horizontal, but this time you're lowering, you're dropping the angle. So that one would be the angle of depression, spelt very badly, I just noticed. Anyway, of X from Y. But of course, the interesting thing about that is the angle of elevation is equal to the angle of depression. You've got alternate angles there if you think of it. So if I'm looking up at a person who's on that fan up there, yes, I saw people look, spinning around, getting very dizzy. But if I was to look up, the angle of elevation I'm looking up would be equivalent to the angle of depression, well, once he turns around and gets to the right spot, when you're looking at me. They would be the same angles. Compass bearings. Now, when we have compass bearings, if it's not one of the main compass points, we divide it in half and they become northeast, southeast, southwest and northwest. So north and south take priority. But of course you could divide it in half again. And when it comes to the naming, you go to the most important one. So the first one there is north-northeast. The next one is east-northeast and so on. And theoretically you could keep going. If I was to divide again, then halfway between north-northeast and northeast would be northeast, north-northeast. And it gets very complicated very quickly, so we don't do that. But theoretically you could. That's why we have these things called true bearing. But it doesn't fall exactly on one of those divisions. And for a true bearing, you always start at north and measure clockwise. So if I wanted to find the bearing of Y from X, so we put the compass at X. Now if I worked out that angle there is 30, then the bearing, start at north, go around clockwise, is 120 degrees. Some people put a T after that to say it's a true bearing, so 120 T. I think the main thing is it has to be 3 digits. So if it was, say, 20 degrees, you'd write 020 for the bearing. If I did it as a compass bearing, we could still do it that way. But again, we would start at the main one, which in this case would be south. And how many degrees did I then go to the other one? So south, 60 degrees east. I could do it that way. If I wanted of X from Y, well, now I put the compass at Y, a little bit of geometry, I could work out that's 60 degrees. So my bearing, start at north, go clockwise, would be 300. Or north, 60 degrees west. Yeah, 2 to 5, pick some.